Episode 8, and the last of the Evolve segment. Episode 7 drew a line and stayed on one side of it. The optimizer and the thing being optimized were separate objects. This episode crosses that line. And I want to set an expectation before we start, because this is the topic where the gap between what is demonstrated and what is claimed is widest in the whole field. This episode describes mechanisms. It does not make claims about recursive self-improvement capability, and by the end you will see that the field's own measurements do not support such claims either, which is a more interesting position than it sounds. That position is unusual for a survey-style episode, and I will defend it. Here is the setup in 3 sentences. The patch is written by the agent, proposed by the same system it will modify, with nothing outside the loop drafting it. The patch is applied to the agent, so after it lands, the thing that would review the next patch is not the thing that reviewed this one. And the patch is evaluated by the agent, which means the score saying it helped comes from a component the patch was allowed to touch. 3 sentences, 3 places this goes wrong. The rest of this episode is how people build it anyway, and what they put around it when they do. Every mechanism in this episode is a partial answer to one of those 3. Episode 7 ended with 1 sentence, and this episode begins with the same sentence. The representation is the agent's own code. The operators are edits it writes. And the evaluator is one it selects. In episode 7 those were 3 separate design decisions, taken by 3 different parties. A researcher chose the representation, a paper defined the operator set, a benchmark supplied the evaluator. Here they are one decision taken by one party. That collapse is the entire premise of this episode, and every safety mechanism in the second half of it is an attempt to prize one of the 3 back out. Prizing one of the 3 back out is what containment means, concretely. 3 objectives. State precisely what a self-referential agent modifies and what it cannot verify about its own modifications. The second half of that sentence is the more useful half. Explain what an archive of stepping stones buys that a greedy hill climb does not. And write a containment specification, which is the one deliverable of this episode you could apply tomorrow. One framing rather than a disclaimer. Every capability figure here is tied on screen to the setup and budget that produced it, where a source reports no figure none appears, and nothing is extrapolated to larger scale. Where a source reports no figure, the slide says so rather than reaching for one. The clearest instance starts from a scaffolding program, a piece of code that structures multiple model calls to produce a better output for some task. Call it the improver. Now apply that improver to its own source code. The product of the outer loop is not a better answer to the task, it is a better answer improver, and that is what makes the recursion real rather than rhetorical. The starting point is a seed improver written by hand. Utility is measured on a downstream task, and meta-utility is how well an improver improves improvers. 3 different models were used, so the finding is about the setup rather than about one model. It helps to be exact about what gets edited, because the word self-improvement covers 4 very different things. Layer 1 is task code, the solution to the problem in front of you. Layer 2 is the scaffold, prompts, control flow, tool wiring. Layer 3 is the improver, the thing that proposes changes. And layer 4 is the evaluator, the thing that decides whether a change was good. Almost all published work edits layer 2, and episode 7 edited layer 2 from outside. This episode is about 3 and 4. The danger is not that they are higher up. It is that editing 4 removes the only check on editing 3. Here is the loop. The agent reads its own source, writes a diff, and reruns itself under that diff. If the score improves, the diff is kept and the archive grows by one entry. 2 things to watch as it runs. First, watch which box the arrow returns to, because it is the same box the arrow left. That is what self-referential means, and it is worth seeing rather than being told. Second, watch where the evaluator sits. It is inside the loop boundary, not outside it. Every containment mechanism in the second half of this episode is an attempt to move that one box out. Moving that one box out is the entire second half of this episode. And here is the part one would put in front of anyone about to build this. The seed improver's evaluation call carries a sandbox flag set to true, with a comment right next to it saying not to change it. The paper then measures how often the generated code runs unsandboxed anyway, over 10,000 improvement attempts. Both models did it, on a small but non-zero fraction, GPT, for at 0.42%, GPT, 3.5 at 0.12. Then they added an explicit warning, and the rate did not fall. Both went slightly up, within overlapping intervals. A sandbox here is not a formality. It is the one slide here I would put in front of a governance committee. The second family makes the agent's own logic part of its editable state, which sharpens a distinction worth holding onto. Editing a workflow leaves the set of possible future edits unchanged. A bad edit degrades this run. It can be reverted by anyone who can read the diff, and the thing doing the editing is a fixed point you can reason about. Editing the editor changes the set of possible future edits. Some become expressible that were not, and others become unreachable. A bad edit degrades the process that would have caught it. And there is no fixed point left to reason from. Which is why the layer stack 2 slides ago put the improver above the scaffold. So here is the structural whole, stated as precisely as I can. An agent cannot establish that a modification improved it using only an evaluator it is permitted to modify. 3 notes on that. It is not a claim about the agent being unreliable, it holds even if every component works exactly as designed. It is a property of the loop, the same object supplies both the change and the standard the change is judged against. And therefore the fix is not a better agent. The fix is an anchor the agent cannot reach, which is a design decision rather than a capability, and it is what episodes 9 and 11 are about. One clarification, because this argument gets dressed up and the costume is misleading. It sometimes appears as an incompleteness result, a formal impossibility about systems reasoning over themselves, invoked to make the limitation sound deep and permanent. It is not that. It is a statement about a loop with no external anchor, which means it is fixable by adding one, a held-out evaluator, a human review gate, or rollback path somebody else controls. And the distinction is practical rather than pedantic. A theorem would tell you to give up. An unanchored loop tells you what to go and build. Dressing an engineering gap as a theorem is a way of not fixing it. The third family adds a population and an archive, and the archive keeps variants that scored worse than what is already held, which is the part that needs justifying. The greedy version keeps the best and discards the rest. The archive version keeps a spread. Keeping something worse is only rational if the path to a better optimum can run through a worse intermediate, so an archive is a bet about the shape of the landscape, and it is a bet you are making whether or not you state it. In episode 2's language it is a store with a write policy, no update path, and a deliberate refusal to forget. The argument in 3 rows. Generation 1 scores something, and it is the best so far, so it is kept. Generation 2 scores worse, and this is exactly where a greedy search discards it. Generation 3 descends from Generation 2 and scores better than either, which makes it unreachable from Generation 1. That is the stepping stone argument, and I want to flag that the three numbers on this slide are illustrative. I made them up to show the ordering. The ordering is the whole claim, and inventing an ordering is fine as long as I say so. Inventing a result would not be. Saying which numbers are invented costs one sentence and buys the rest of the slide. 1 landscape, 2 searches. The greedy climber reaches a local peak and stops. Every neighboring step is worse, so there is nothing left it will accept, and it has no way of knowing whether it is at the top of a hill or the top of the mountain. The archive-based search takes a step down, keeps that worst point, and from there finds a path past the ridge. And watch the counter, because the cost is the honest part of this picture. The archive search evaluated more candidates to get there. It bought the escape with evaluations, which is the same currency episode 7 was denominated in. Escaping a local optimum is bought with evaluations, like everything else here. One more thing about archives, and it connects straight back to episode 7. When a benchmark saturates, an archive-based search does not stop. It keeps producing variants that score identically and differ in ways the benchmark cannot see. Those differences are not noise, they are the part of the behavior nobody is measuring, and the search is free to move in that space at no scored cost whatsoever. So a flat score curve after saturation tells you the search stopped being observable, not that it stopped. Which is episode 7's 2 curves again, wearing different clothes. A benchmark that has stopped discriminating is no longer measuring. It is only agreeing. What does a working system in this family actually change between iterations? The edits are small and mostly infrastructural: tool wiring, retry logic, how context gets assembled, how results are cached. And most proposed edits are rejected rather than applied. The accept rate is the operative quantity here, and it is low. That reframes the whole activity in a useful way. The system is not walking uphill. It is generating candidates cheaply and discarding almost all of them. I am not putting an accept rate number on this slide, because our verified record does not carry one, and the qualitative fact is the part one can stand behind. Low accept rates are good news. Incidentally, they mean something is filtering. Now the precondition, and it turns out to have a precise name. A harness constructs prompts, manages state, invokes tools and coordinates execution, and any single behavior you might want to change is usually spread across several of those places. Finding all the implementation sites for one described behavior is named as the central bottleneck in harness evolution, and it is called behavior localization. Organizing code by files and functions does not help, because behavior does not live in one file. A behavior-centric representation does. Notice what that reframes. Legibility is usually argued on grounds of taste. Here it is a named bottleneck sitting in the path of every self-modification. Which lets me put a claim on screen and mark it as mine. If a human cannot read the harness, evolution is indistinguishable from decay. What supports it is not intuition. The localization bottleneck is real, named and measured, and a behavior-centric representation improves both localization and edit plan quality on modification requests from 2 open-source harnesses, while using fewer planner tokens. And here is the test to apply instead of the argument to have. Can you review one generation's diff in under an hour? If not, you cannot tell an improvement from a regression, and your archive is accumulating both. An hour is not arbitrary, it is roughly the attention a reviewer will actually give. There is a second half to the legibility question, and it points the opposite way. What if you do not modify the harness at all? Given only the ability to proxy the model calls a harness makes, reinforcement learning can be run against that harness without controlling it. The harness becomes an environment rather than a code base, and a trainer can improve the policy inside somebody else's scaffolding. Reported on SWE Bench verified with a 4 billion parameter model, plus 22.6, plus 4.8, plus 0.6, and plus 6.2 points across 4 harnesses. Read the spread rather than the best number. A method that varies 22-fold across harnesses is telling you about harnesses. Put those two together, because they look contradictory and are not. One line says the harness must be readable, because a human has to review what changed, and localization is the bottleneck that makes review possible at all. The other says the harness need not be readable, because if you only train the policy inside it, you never edit it, you proxy its model calls and treat it as an environment. Both are true. They are requirements for different things. The first is what you need if the harness is what evolves, the second is what you need if the policy is. One is a claim about people, the other about interfaces. Let me put the evidence base of this whole episode on one slide, because I think its shape is the most important thing in it. 3 things are measured. Safety behavior under self-modification, circumvention rates, with intervals, and a denominator. Capability under a fixed external benchmark, scores against named baselines. And infrastructure, localization quality, and policy gains across 4 harnesses. One thing is not measured anywhere: what a system does when the evolution budget, the benchmark, and the human review gate are all removed. Nobody ran that. So the unbounded case is a topic, not a result, and that is why this episode makes no capability claims. The last family moves the unit of evolution. Instead of one lineage improving itself, a group of agents is the evolutionary unit, with experience shared and reused inside the group, so what one agent learns is retrievable by the others, and the group carries the improvement forward. Reported, 71% on SWE Bench verified against 56.7 for prior self-evolving methods, and 88.3 on Polyglot against 68.3. Now the comparison worth reading carefully. The strongest human-designed frameworks score 71.8 and 52. So on one benchmark this matched and did not beat, on the other it nearly doubled. Both halves of a mixed result belong on the slide, not only the favorable half. And here is the cost of that channel. A group with a shared experience store, one agent records something that turned out to be wrong. The others retrieve it, act on it, and record their own experiences downstream of it. Watch the spread, and watch what does not happen. Nothing in the loop marked the original entry as wrong, so nothing stopped it. This is not a flaw bolted onto the design. The channel that made the group learn faster than an individual is the same channel that turns one agent's error into everybody's error, and you cannot have the first property without exposing yourself to the second. Faster shared learning and faster shared error are the same mechanism. 2 handoffs, and they are the reason this episode sits where it does. Episode 9, nothing in that loop detected the bad entry, not because the detector was weak, but because there was no detector. The group's own agreement was standing in for verification, which is the self-confirmation trap at population scale. Episode 10, a shared store that propagates entries without checking them is an attack surface. One write, many readers, no gate. And that closes this segment. Everything in Evolve made agents change themselves. Nothing in it established that a change was an improvement. That sentence is the hinge of the whole series, and the next segment answers it. So here is the deliverable, and it is 4 parts written down before the first self-edit runs. An evolution budget: how many generations, how much compute, and what happens when it is exhausted, because a budget with no exhaustion behavior is not a budget. A sandbox boundary: what the agent may touch, and remember slide 8, because the circumvention rate is small and non-zero and unmoved by warnings. A rollback path: who can revert, from where, without the agent's cooperation. And a stopping condition, written in advance, in terms someone other than the agent can evaluate. That last phrase is the whole point of the exercise. A stopping condition the agent can evaluate is not a stopping condition. Lab 8. Fill the containment template for one agent of your own: budget, sandbox, rollback, stopping condition. For the stopping condition, write it in terms a colleague could evaluate without asking the agent anything. That constraint is doing all the work. And if you cannot complete that 4th field, you have your answer, and it is that you are not ready to let it self-edit. The template is in the repository. This is the only lab in the series whose output is a decision rather than a measurement, and the 4th field is where teams usually discover they were planning to rely on the agent's own judgment. The 4th field is the one that tells you whether you meant any of it. 5 takeaways. All 3 of episode 7's choices collapse onto one subject here, and every safety mechanism is an attempt to prize one back out. For layers are editable, and editing the 4th removes the only check on editing the 3rd. An agent cannot verify its own improvement using an evaluator it may modify, an unanchored loop rather than a theorem, so it is fixable. Sandbox circumvention was measured at under 1% and non-zero, and an explicit warning did not reduce it. And what this field measures is bounded, externally evaluated self-modification. The unbounded case is a topic rather than a result. Next, verification, which is the missing half.